Good morning, everyone. Myself, Ritika Chetipelli from CSC Branch Section D. Today, I am going to present a PPT on topic called palindrome permutations of course essential problem solving. First, what is a palindrome? Palindrome permutation is the possibility of rearranging a string into a palindrome. This is possible if at most one character in the string appears an odd number of items and all other characters appears an even number of items. For example, the string AAB can be rearranged into ABA, which is a palindrome. Exploring palindrome permutations. Palindrome permutations are fascinating arrangements of characters that can form palindromes. Understanding these permutations involves combinator analysis and character frequency. This presentation will develop into the criteria for palindrome formation, explore examples, and demonstrate how to calculate the number of unique palindrome permutations using factorials and combinations. By the end, you will grasp the mathematical beauty behind these systematic sequences and their applications in computer science and engineering. Definition of a palindrome. A palindrome is a word or a phrase that reads the same backwards as well as a forward, such as level or race car, showcasing symmetric in letters arrangement. Understanding permutations. Permutation is a rearrangement of letters in a word. For example, the word ABC can be permutated to ACB, BAC, and others, totaling 6 combinations. Formatting palindrome permutations. Palindrome permutations can be formed from the letters of a word if at most one character has an odd frequency. For instance, AAB can form ABBA. Computational relevance. Understanding palindrome permutation is crucial in componential problems like string manipulation and cryptography, where symmetric and rearrangement plays vital roles. How to determine the palindrome permutations? First, count character occurrences. Analyze the input string and count the occurrence of each character using a frequency map. Check odd counts. Examine the frequency map to ensure that at most one character has an odd count, which is requirement for forming a palindrome. Next, step 3. Generate permutations. If the character counts are valid, generate all possible permutations of the character. Valid palindrome property. For each generated permutation, check if it reads the same forwards as well as backwards to confirm it is a palindrome. Example, AABB palindrome permutations. Character counts. In the string AABB, character counts are A, 2, B, and 2. B also 2. Both characters have even count, confirming that is a palindrome can be formed. Valid palindrome. Since all characters have even count, AABB can be rearranged into a valid palindrome such as ABBA or BABB, demonstrating symmetry. Possible permutations. Permutations of AABB include ABBA, BABB, and others. Each permutations can be rearranged to form a palindrome showcasing versatility. Here is a flowchart how to generate a palindrome permutations. First start point. Count character preferences. Odd frequency check. If yes, generate half permutation and endpoint. If it is a full frequency check, no. Return to no palindrome. Here a graph shows a character frequency analysis for palindromes. Here blue color represent A, green represent B, and C represent and orange represent C, and red represent D. Impact of palindrome checks. 1 million plus string tested and palindrome validation. 90% efficiency in string manipulation task. Significant reduction in computational overhead. Burette Burette force versus optimized approach for palindrome permutations. Burette force method optimized approach. Burette force method generates all possible permutation of the string, whereas optimized approach utilizes a direct character count to determine potential palindrome permutation formations. Palindrome formations. Time complexity of O(n) factorial making inefficient for large data sets. Time complexity of O(n) making it highly efficient even for large data sets. Requires significant memory to store all permutation before checking for palindromes, whereas for optimized approaches requires minimal memory as it only needs to track character frequency. Next questions. Questions. All string form palindromes? Not all string can form palindromes. A string can be rearranged into a palindrome if at most one character has an odd frequency. How do I handle spaces and punctuations? When checking for a palindrome permutation, ignore spaces and punctuations by focusing only on the character. There are limits on string length? While there are no strict limits on the string length, performance may vary. Longer strings may require more efficient algorithms to check a palindrome permutations. What algorithms are best for palindrome checks? Common algorithms include character frequency, counting, and using hash maps, which efficiently determine if a string can be rearranged in a palindrome. Palindrome permutations can be used in many ways in general life. Count character frequencies. Determine how many times each character appears in the string. As I told the steps. Next. We can print all palindrome permutations using code. Key takeaways. In summary, palindrome permutations reveals fascinating insights into a string manipulation and combinatorial mathematics. Key points include the importance of character frequency, the role of even and odd counts, and practical applications in code challenges. Understanding these concepts not only enhances problem solving skills but also prepares us for more complex algorithm tasks. As we are advanced exploring, further application in data structures and algorithm will be deepen our comparison and proficiency in this area. As we all know, palindrome permutation is a rearrangement of a string that can form a palindrome. This is possible if at most one character appears an odd number of times in the original string. For example, same I said AABB or BACAB, both of which are palindromes, but AABBCD cannot form a palindrome because both C and D appear odd number of times. Only one character should appear in odd number of times. Remaining all should be an even number of times. Palindrome permutations are used in many ways. If we take an example of AABB palindrome permutations, first we have to count the character counts. In the string AABB, character counts are A and B, which are 2, 2. Both characters have even count, confirming that a palindrome can be formed. Next, we need valid palindrome. Since all characters have an even count, AABB can be arranged into a valid palindrome such as ABBA or BAAB, demonstrating symmetry. Possible permutations. What are the possible permutations for AABB? The possible permutations include ABBA, BABB, and others. Each permutation can be rearranged to form a palindrome, showcasing its versatility. The palindrome number should read same from forward and backward. Then we can say that it is a palindrome number. Thank you, everyone.